Hey Space Watchers, and welcome back here from Paris. We are still at the 7th Summit of Space Sustainability, and I have the great pleasure to speak now to one of the very impressive speakers that we heard here over the last days, and that is José Ferreira.
Very well done, Torsten.
Thank you very much. So it was thin ice for me. José, tell us more about you and your work.
Of course. Firstly, thank you for having me, and it's a pleasure to be talking to you, to your audience, and to have had the floor here at the Summit for Space Sustainability in Paris to talk more about my work and what I've been doing in the last couple of years. So within that context, I come from the University of Southern California, where I've been developing this research line on resolving the atmospheric impacts of spacecraft demise, or if we want to put it in another way, anthropogenic object demise, human-made object demise in the atmosphere. So this is a very interdisciplinary subject that essentially mixes and crosses, overlaps material science, chemistry, aerothermodynamics, atmospheric sciences. It's complicated, to put it simply. And essentially the contribution that I hope to have brought to this discussion is where we are right now, what do we know, and where we are heading. And essentially what I hope to have set the floor for is what is the research that has been done, what do we know, but mostly what we do not know, and how can we address these knowledge gaps to move forward to a clear idea of the subject.
That's a great point. So elaborate it a bit more for our audience. And honestly, I was listening to your presentation yesterday and I tried to understand it. And as you said, it's complicated, and I absolutely second it, because I understood a fraction of what you said. So, I mean, for me, two questions arise. So, what is the issue? Okay, we're burning satellites or human-made objects in the atmosphere, and what is the impact? So, and then, do we have to change something with that? I mean, these are more or less three questions. So, but can you elaborate again where we stand on that? Because what you said, we don't know, that is something what you not hear so often from a scientist.
Exactly. And I think it's part of the intellectual humility of a scientist to say that we don't know. And I think as the more we know, the less we actually, the more we understand that we don't know about something. So putting it simply, anything that enters the atmosphere from orbit or from the interplanetary media enters very fast, which means that as it faces the atmosphere, it will increase its temperature and essentially burn up. So this is the process we are referring to. We know a little bit about this process by re-entering objects from the atmosphere. I mean, we went to the moon and we had to master this to be able to enter the atmosphere safely and bring our astronauts home. So this is something that we have known about a little bit since the last century. The question here now is understanding how these spacecraft that essentially populate more and more Earth's orbit, how they re-enter in the atmosphere and how essentially do they de-integrate in the atmosphere, which is, by the way, exactly the opposite of what these capsules that return humans home do. And this is the question mark. This is essentially the decisive factor that will then help us understand whether or not there are negative or positive environmental impacts. So we actually don't understand very well how big these particles are and what are the chemical byproducts of these satellites and anthropogenic objects. I like to put it that way because it includes also some remnants of launch vehicles and so forth. So I'd like it to put it in a more broader way. But the question is that for as long as we do not understand how small these particles are, essentially the technicality, the base science behind it, it's very difficult to then make concisive claims about a negative or positive environmental impact. However, the rising number of anthropogenic objects in orbit is essentially a wake-up call for us to dedicate more time, and time is money, so resources, to further develop our knowledge in this very intricate and interdisciplinary research field.
If there was one thing that I picked up from your presentation was that the aluminium, I hope that's correct, right? Or the level of aluminium that is in the upper atmosphere is increased to a level above what it was with the material coming from meteoroids, or from these kind of objects that coming also onto our atmosphere. So and then just to put it into relation, so the amount of natural objects that hitting the Earth are still much higher than our human-made ones. Correct?
I like to put this history in the following way. So we live in an atmosphere that was built upon several billions of years, and to which interplanetary meteoroids, interplanetary dust contributed to. So in some way we can think that we are actually breathing something that comes from space, right? So this is the natural level. This is the baseline. Mm-hmm. Now what we need to compare against is with the increase of human-made objects that re-enter the atmosphere. Right. If we just compare it in terms of pure mass terms, it will probably be a drop in the ocean. So much more. There is a much higher mass re-entering from meteoroids than from spacecraft. But then we need to analyze the actual chemical species that we are concerned about. Yeah. And then you pointed correctly. I presented the use case of aluminum, but you can think of other chemical species that may concern other experts, such as I know there are other scientists that are concerned with lithium. Some others are concerned with copper. So essentially, pick your poison, talk with your preferred scientists, and they may point you to a different chemical species.
I see. Okay.
So this is where the whole community needs to come together and first understand what are the actual chemical species that we are concerned about, and then start monitoring them, start understanding what are the actual byproducts that derive from the reentry, and then starting advancing our knowledge. Essentially, what I showed yesterday is a very, very simple case study where we look at the aluminum that comes from natural objects and compared it against human-made objects, and we see the increase on the anthropogenic side, and then that we are already surpassing the natural content with regards to aluminum, according to the estimates I presented, with a level of confidence of 95%. That's what I presented yesterday. But then we can do the same reasoning for other species and then derive similar or different conclusions depending on the mass fraction.
If you look ahead and try to project where we are going, I mean, with this more or less exponential growth and access to space, masses into space. I mean, if Starship comes online, then it increases again. Europe is awakening, I mean, not on this mass factor, but also putting up more materials. So will there be a tipping point that our atmosphere might flip, might not flip? Because you didn't talk about the impact, because we don't know. And when you listen to many of the publications that are online, there's impact that could be, hey, that's good because our climate change or the overheating of Earth will be lowered because of that. Well, I think with my humble view, oh gosh, if we are on that point, then something really terrible goes wrong, or it has a negative effect as well. But is there a tipping point where you say, in 3 years, in 5 years, if we haven't done that, then that will happen?
Spoiler alert, I'm going to disappoint you again by being a very a very scientist and saying we do not know enough about it to say that there is a tipping point. And this is probably a chicken and egg problem, wherein we need to further understand the process to say whether there is a tipping point. I would like to firstly clarify more on the semantics of what is an impact, because the way I view it, and of course this is debatable, an impact is a change in the status quo. So given that we are changing the amount of a given chemical species that is present in the atmosphere, then therefore we may say that there is an impact. What we do not know is whether this impact is positive, neutral, or negative. And to your point, it may even be the case, and we need to be intellectually humble to consider as a potential outcome that the impact is positive, that we are actually cooling down the planet. Yeah. But the point you're raising is, if there is a tipping point, then the impact is negative. Yeah. And should we stop doing what we are doing now? And this is the question that I believe bring us all to this sort of discussions, which is, if we wait for the consequences to become clear, then we are concerned that it may be too late. And then that answers the question to the tipping point. But I believe it's still too early to crystal clearly claim that there is a negative impact.
That's absolutely fair. As we are heading towards the ESA ministerial conference, and we're talking about the contribution of the member states into the big ESA pot for funding, for research, for project, does this kind of studies have enough funding to get us an answer in a reasonable time frame?
That is a very interesting question, Torsten, which I'm not sure if I'm the best.
Funding, potentially.
And I may be I may not be the right person to answer that. What I can say is that I see an increase on the awareness about this subject and on the resources devoted on this subject to further the knowledge on it. So if we look 2 or 3 years ago, potentially no one would talk about this, and there were no dedicated sessions in fora like this to discuss this subject. And I also know that noteworthy space agencies and institutions are devoting, are essentially opening funding streams to source and to essentially advance the knowledge.
Can you attribute that? I mean, I know about the UK Space Agency, which is very active in it. Is there any other agency that you would like to mention that is on a positive side?
I would say that on the European level, it's very positive to witness the increasing interest on this subject. And I see that there is more effort and funding being devoted also to lab experiments, which I think will tell us a lot about these scientific details, the actual nitty-gritty of what's going on. But I believe that this is the time to make a call for a global effort. I think this is not a one country or one political bloc effort. This should be a global endeavor to advance knowledge on this, because I mean, space is a global commons, and it's in our interest to advance our knowledge on this, to further to make sure that we are doing the right thing and protecting a global commons, and that we can all essentially benefit from it in the shorter to long term.
Great. José, thank you very much for your time and bringing that up. I mean, also to my knowledge, I'm very open. I haven't seen that before. I heard about it, I read about it, but yeah, it's somewhat what goes in the noise. But I'm quite sure, and that's a promise, it's not the last interview that we have on that. And with that, thank you very much for listening, and Space Watch out.